What if all the ice on Earth melted? That question conjures dramatic images. Submerged coastlines, vanished glaciers, and massive migrations. Yet it's more than a sci-fi scenario. It's a genuine concern as global temperatures climb. Let's unpack what a world without ice would mean for cities, ecosystems, economies, and the very fabric of life on Earth. Number 1. The vast reservoir of ice. We often picture Earth's ice as polar caps and glaciers, but the sheer volume is staggering. Antarctica alone holds around 90% of our planet's ice, with Greenland containing the bulk of what's left. Mountain glaciers spanning the Himalayas, the Andes, the Alps, and elsewhere make up a smaller but still critical portion of this frozen reserve. Together, these ice masses store tens of millions of cubic kilometers of water. If it all melted, scientists estimate sea levels could rise by more than 60 meters, about 200 feet. That wouldn't happen instantly. We're talking centuries or millennia. Still, once ice melt accelerates past a certain point, reversing it becomes nearly impossible. The balance of nature would tip irrevocably, changing coastlines and climates for future generations. Number 2. Cities at risk. Rising seas. A 60-meter sea level rise would redraw the world's maps. Many megacities, New York, Shanghai, Mumbai, perched just a few meters above current sea levels. London, Amsterdam, Tokyo, and countless coastal towns would face partial or total inundation. Entire neighborhoods, industries, and cultural landmarks would vanish under the sea. Alongside flooding, storm surges would worsen, as higher baseline water levels amplify hurricane and typhoon damage. Saltwater intrusion into aquifers near coastal areas could spoil drinking water, while farmland would suffer from rising salinity. With so many populations forced to relocate, we'd see massive migrations, some of the largest in recorded history, causing intense stress on infrastructure, healthcare, and social systems in safer inland areas. Number 3. Vanishing glaciers and freshwater crunch. Beyond coastlines, mountain glaciers act like natural water towers, slowly releasing meltwater into rivers. Regions like South Asia depend on Himalayan glaciers, feeding rivers such as the Ganges, Indus, and Brahmaputra. If these glaciers disappear, seasonal flows could become dangerously erratic. Floods might grow more severe in rainy periods, while dry seasons could bring acute water shortages. Agriculture in these areas would face unprecedented challenges, as consistent irrigation relies on predictable glacier melt. Hydropower facilities, which use river flow to generate electricity, would also struggle with unstable water levels. Millions of people could face chronic water scarcity, undermining local economies and creating potential flashpoints for conflict. Number 4. Climate feedback loops. Ice isn't merely frozen water, it's a major climate regulator. Vast expanses of white ice and snow reflect solar radiation back into space, helping stabilize global temperatures. As ice retreats, darker land and ocean surfaces absorb more heat, accelerating warming. This feedback loop worsens the melt, pushing temperatures higher. Warmer oceans fuel more intense hurricanes and typhoons, extending them into regions unaccustomed to such ferocity. Heat waves could grow longer and more frequent, disrupting agriculture, health systems, and infrastructure worldwide. Shifting rain patterns might also create drier, more fire-prone conditions in some regions and excessive rainfall in others, intensifying weather extremes that test human resilience. Number 5. Ocean currents and marine ecosystems. Melting ice sheets dump vast amounts of fresh water into the ocean, reducing salinity and potentially weakening major currents, including the Gulf Stream. These currents transfer heat globally, helping moderate coastal climates. A slowdown or redirection could trigger abrupt weather shifts. Europe, for instance, might cool under weaker warm currents, even as the rest of the world keeps warming. Meanwhile, marine ecosystems depend on stable salinity and temperature patterns. Coral reefs, already under threat from acidification, could collapse faster in regions slammed by changing currents. Fisheries might shift range or decline, upending coastal economies. Invasive species, less hindered by temperature changes, could spread more easily, further stressing delicate marine balances. Number 6. Colossal economic and social costs. When sea levels surge and weather extremes intensify, the economic toll is immense. Coastal cities are global economic engines, centers of finance, tourism, and industry. Flooding disrupts ports, rail lines, and highways. Insurance premiums could skyrocket, and some properties might become uninsurable. Building massive seawalls or relocating entire populations requires staggering sums of money. And even then, such solutions are often temporary. Mass migrations loom as people flee submerged homes and ruined farmland. Internal movement within countries strains resources, sparking tensions. Internationally, climate refugees could number in the tens or hundreds of millions, placing enormous pressure on neighboring nations. In many cases, these challenges wouldn't be short-lived. Reclaimed land may remain uninhabitable or at permanent risk of flooding. Number 7. The extinction threat. Icebound habitats vanish when glaciers and polar ice recede. Polar bears, penguins, seals, and other cold-adapted species lose breeding grounds and hunting territories. Entire ecosystems, like krill-based food webs in Antarctica, face disruption. As sea ice retreats, algae blooms may shift, harming krill populations and the larger animals that depend on them. On land, species adapted to cold environments could see entire ecosystems fragment or disappear. Some might migrate upslope or poleward, but there's often a limit. If that route is blocked, extinction risk soars. The resulting upheavals ripple through food chains, undermining biodiversity, pollination, and even natural pest control, ultimately affecting human food security. Number 8. Adaptation and innovation. Despite dire forecasts, humans are resourceful. Faced with ice-free scenarios, countries might race to develop new adaptive technologies. Coastal cities could invest in radical architecture, floating neighborhoods or higher sea walls. Advanced desalination plants might ease freshwater shortages. Engineered wetlands, oyster reefs, and mangroves could serve as living barriers, reducing wave impact and providing habitat. Transitioning to renewable energy sources could accelerate. Nations might prioritize solar, wind, and other green technologies to slow further warming. Innovative infrastructure, like climate-resilient roads and flood-proof transport systems, would emerge. While these efforts cost billions, they might also fuel economic opportunities, spurring research, entrepreneurship, and global cooperation around sustainable solutions. Number 9. Impact on global society. A planet without ice exposes global interconnections. Agriculture depends on stable water, coastal hubs drive trade, and polar regions regulate climate. Melting ice heightens vulnerabilities, straining politics and disaster response. Displaced populations challenge social cohesion, while resource conflicts or cooperation shape the future. Our response could redefine civilization, collaboration, or crisis. The choice is ours. Conclusion. Imagining Earth without ice reveals our fragile balance. Rising seas, extreme weather, and ecological shifts show climate change's reach. Partial melting already fuels crises, flooding coasts, damaging habitats, and stressing food supplies. Solutions exist, from renewables to resilient cities, but urgency remains. Stay curious, stay informed, subscribe for more insights on shaping a sustainable future.